This is the introduction to section 2.6, part 1. And in this section, we're going to prove and apply theorems about angles. Okay. So, first thing we want to talk about here is, what is a theorem? A theorem is a conjecture or a statement that you prove true. Now remember, a conjecture is some conclusion that you come up with that is true. Okay? And what a theorem does is a theorem proves this conjecture to be true. Okay? So a theorem proves a conjecture to be true. Now, the first thing that we're going to look at here, and as you look at the essential understanding here as well, you can use given information, definitions, properties, postulates, and previously proven theorems as reasons and proofs. And if you remember, as we've looked at 2.5, and we've spent quite a bit of time on 2.5, we've used definitions, information, given information, properties, postulates, all those types of things. And we're going to start to learn some of these theorems as we go along here. Okay, so very first theorem we're going to look at, Theorem 2.1, it's the vertical angles theorem. It says, vertical angles are congruent. So, if you are a vertical angle, then you're congruent to each other. All right, and what it says here is vertical angles, in this case, angles 1 and angles 3 are vertical. They're congruent to each other. Angles 2 and angles 4 are vertical. They're congruent to each other. Okay, so using this information from this theorem, we're going to look at some examples, okay? And what we're going to do here to start is we're just going to have you go through some examples before we start diving into the proof stuff. So it says here, what is the value of x? Okay? Well, you'll notice these two angles are vertical angles. They form two straight lines that intersect into a shape of an x. So since they're vertical angles, we know that these two angles, 2x plus 21, and 4x are equal to each other. Okay, so now all we want to do is find the value of x. So I'm going to subtract 2x here. So 21 is going to be equal to 2x. And in this case, we divide by 2. X is going to be 10.5. Now, in some cases they may ask you, find the measure of the angles. Well, if that's the case, then you would plug it in. If I did that, you'd have 4 times 10.5, which in this case would be 42. That would be the measure of that angle. Well, if to check it, I want to make sure that it's included in the other one, I'd do the same thing. So I would take 2 times 10.5 plus 21, which 2 times 10.5 is 21, plus 21 is 42. We know these two have to be the exact same. Okay? So they may ask you sometimes find the value of the angle as well, along with the value of x. Okay. All right, so let's take a look here. The one thing that I want you to do on your problems, okay, is to complete this example. Okay, find the value of x. And I'm also going to ask you to find the value of each angle as well. Okay, so make sure you do that as well. So find the value of x, find the value of each angle. Okay, make sure you have that done before class starts tomorrow. All right, now let's take a look over here at this stuff on the left. It says, when you're writing a geometric proof, it may help to separate the theorem you want to prove into a hypothesis and conclusion. Another way to write the vertical angles theorem is if two angles are vertical, then they are congruent. Okay, the hypothesis becomes the given statement, the conclusion becomes what you want to prove. Okay, so here, as you look at this example, they give you an example of proving the two angles are vertical, then they're congruent. If two angles are vertical, so here's the two angles, they're vertical, that's the first statement. What they're saying is then, you can make the conclusion, they are congruent, right here, your part that you want to prove. So, what they've said here is that angles 1 and 3 are vertical angles, that's given in this given statement. Statement 2 says, angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. So 1 and 2, 2 and 3 are supplementary to each other. Now, you could also use, in this case, the definition of supplementary angles. Now, sometimes the book is going to give you a reason that's a little bit different than what we have put together. Okay, it's the same thing. We've just tried to shorten it a little bit for ourselves. All right. So we say they're supplementary. Well, if we say that they're supplementary, then the two angles are going to add up to be 180 degrees, which again, this says the sum of the measures of supplementary angles is 180. Again, you could put down here as well, definition of supplementary angles. Okay. Now, some of you are asking about the transitive property. Here's a great example of the transitive property. And I'm going to zoom in on this so that you guys can see a little bit better. Notice we say, to start here, that angle 1 plus angle 2 is 180. Okay, that's the first part. Angle 2 plus angle 3 is 180. Okay, now, if both of these are equal to 180, then they're both equal to each other. Okay, they're both equal to each other. So I've got three things that are equal to each other. Here is 1, letter A, here's 2, letter B, and here is 3 things that are equal to each other. That's a great example of the transitive property. 1 plus 2 is 180, 2 plus 3 is 180, then 1 and 2 and 2 and 3 are equal to each other. Okay, so they're using the transitive property in that example. Okay. Now, the next step, they essentially, if you'll notice, they've subtracted angle 2 from each equation. They get the subtraction property. And then the last step is they go from congruent to, or equal to congruent. So this would be definition of congruent angles. That's the same thing as what they have here. Okay, except for they don't say it that way. Okay, on page 2 here in your notes, you'll notice you've got 4 theorems here that we're going to look at. Okay, and these are theorems that we're just going to talk through, and we'll go through examples of a little bit later. But the very first theorem, Theorem 2.2, says that this is the congruent supplements theorem. So what it says here is, if two angles are supplements of the same angle or of congruent angles, then the two angles are congruent. So what they're saying here, when we say supplements, remember they add up to be 180. Okay, so if angle 1 and angle 3 are supplements, so this angle right here, angle 3 and angle 1, these two add up to be 180. And angle 3 and angle 2 are supplements, so these two add up to be 180. Then angle 1 and angle 2 are the same. Now an example here would be, let's say this guy was 100 degrees. If angle 1 and angle 3 are supplements, then angle 1 has to be 80 degrees because they have to add up to be 180. Well, if angle 3 is 100 and angle 2, if those two are added together, have to be equal to 180, this one has to be 80 degrees as well, which means you'll see that these two are congruent. So that's how they come up with the congruent supplements theorem. And we'll discuss kind of how you see that. You're not going to see a lot of that in a proof, but you might see it a little bit. Second one says if two angles are complements of the same angle or of congruent angles, then the two angles are congruent. Here's the same concept except for with complement, which means they add up to be 90. So again, if angle 2 and angle 1 add up to be 90, and then angle 2 and angle 3 add up to be 90, that means 1 and 3 are the same. For example, if this guy is 47, angle 2 is 47, angle 1 would have to be 43 degrees in order for him to add it to be 90. Same thing with angle 3. If angle 2 was 47, angle 3 would also have to be 43 degrees, which means these two guys are congruent. Okay. All right, Theorem 2.4 is one you're going to see a lot. Theorem 2.4 says all right angles are congruent. So what it says here is, if angle 1 and 2 are right angles, okay, and that's what it'll say. Maybe it'll say in the given, 1 and 2 are right angles. Then we can say that 1 and 2 are equal to each other because they're exactly the same. They're both 90 degrees. And the reason here would be that right angles are congruent. You start, if it says they're right angles first, and then the next step were to say they're equal, we know that right angles are congruent. That's Theorem 2.4. You're going to see that one quite a bit, actually. Theorem 2.5, if two angles are congruent and supplementary, then each angle is right angle. If they're congruent, that means they're equal. And they're supplementary, that means they add up to 180. Well, there's only one way for two angles to be equal and add up to 180, and that's if they're both 90 degrees. Okay? So it might say angle 1 is congruent to angle 2, and angle 1 and 2 are supplements. it may be a given. And if it says then that angle 1 is equal to angle 2, or angle 1 and angle 2 are equal to 90, then you would have this reasoning, theorem 2.5. Okay? Now, this concludes section 2.6 part 1. We've talked about some new theorems, talked about vertical angles, and the big focus here is the vertical angles theorem on this first one, okay, on this first part. Don't forget to complete your WSQ along with that problem on that first page.